Hello there friends, welcome to another video on social science research methodologies course. The subject of this presentation is independent versus dependent variables. In previous lectures you learned that in research, especially in the context of social science or social science statistics, variables are any characteristics that can take on different values. Now researchers design and study the variables in the form of independent and dependent variables to test relationship between two or more variables. In other words, they use independent and dependent variables in their forms to study change and effect relationship between two or more variables. Generally, independent variables are also referred to as explanatory or predictor variables. It's independent because it's not influenced by other variables, and it explains or predicts changes in the dependent variable. Now, the dependent variable, on the other hand, is the opposite of independent variable. It's dependent on the changes that's introduced by an independent variable. Again, it's also known as outcome or response variable. So then don't get confused with the naming conventions for each of independent and dependent variable. So independent variable, explanatory variable, and predictor variable, they all mean the same thing. Dependent variable, outcome variable, or response variable, they all have the same meaning. So again, dependent variable is dependent because it's reliant on any changes that are introduced by an independent variable. And lastly, it is used as a measure of effects that's been uh, introduced or based on a change that's been introduced in an independent variable. In order for me to better explain these definitions and put uh, these definitions into perspective and practical understanding, allow me to use two specific examples. Example one, I in example one, let's pretend that I would like to study the relationship between economic prosperity and political awareness. In other words, I would like to test whether there's a relationship between people, how economically prosper uh, people are, and how that relate to their political awareness, how much political information they have. And the hypothesis I introduce is that there is a relationship between economic prosperity and political awareness. I do not specify which one, how this relationship exactly is. If somebody's richer, that person has more political awareness. If somebody's richer, if people who are richer have less political awareness. I did not specify that relationship. Rather, I said there is a relationship between economic prosperity and political awareness. And the test will designate if there's any significant relationship. If there is it a positive relationship where better economic prosperity leads to better political awareness, or is it a negative relationship where it's the vice versa? And so the variables that I use are to test this hypothesis are individuals' income as the independent variable. And the second variable that I use as a dependent variable is a score of individuals' political awareness. So let's say if we have 100 samples to test this hypothesis, 100 samples will, these 100 samples will capture two specific information from the individuals. The first information, which is the independent variable information or data, would would represent individuals' yearly income, how much the individuals make on an annual basis. And the second information or data, which is a dependent variable, is a test score where where you have tested and standardized individuals' scores or political awareness score on the basis of a series of survey questions. And what we do is we look at both of the relationship using a statistical significance test to see if there is any relationship, and if there's any relationship, what is the direction of this relationship. In example two, let's pretend that we're studying the relationship between gender and income. So our hypothesis that there's a relationship between gender and income, and male employees have higher income than female employees. Now, unlike the previous example where I did not specify the direction of relationship, in example two, I actually specified the relationship, the direction of relationship, and I hypothesized that male employees actually make more money than female employees, or male employees are paid higher than female employees. Now, to test this hypothesis, I use two variables of independent and dependent variable, where my independent variable is individual's gender and the dichotomy of male or female, and the second in a variable, being the dependent variable, is their yearly income. Now, while in example one, both of the variables are ratio or numerical data variables, in example two, while our dependent variable is ratio or a numerical data variable, our independent variable, which is a gender, is a categorical or dichotomous variable where we are testing for the change of two gender typologies and how those relate to their income, and to see if there's any relationship and if, between the income of both of the genders. Uh, Hoping that these two examples will be helpful in understanding the actual difference between independent and dependent variable. And lastly, I would like to mention that effect is not always causation, and correlation is not always causation. So, if you're testing or if you're studying a relationship, it does not necessarily mean that you're testing cause and effect. You may be you're looking at two variables, and there may be other control variables or confounding variables that you're not taking into factor. So, to understand this topic in further details, please watch a video on correlationships and also what other variable or control variables are in a statistical test. Thank you for your time and have a great day.